Ionic bonds. By ionic bonds, there's always one atom losing or gaining one of their valence electrons, so the electrons on the outermost shell. And there can be, for example, sodium. Sodium has 11 electrons, 2 on the first shell, 8 then on the second shell, and 1 on the third shell, and that one single valence electron can be given away, and now it becomes with a full octet on the second shell, and it becomes now sodium. And it is now a cation because it has too many protons. It has still these 11 protons, but only 10 electrons. No, it has one too much protons. It has now a charge of +1, because protons are +1, electrons -1. Another example would be the chlorine. Chlorine has 17, and chlorine could gain an electron, has been 18, and it has no electron too much, so it is too much minus. It is now -1, and now an anion. Cation is positive, and anion is negative. And they can come together and form then sodium chloride, for example, and then they have again a net zero charge. All ionic bonds as a compound form together, for example, sodium and chloride, as sodium chloride, they have a net zero charge. There can be such compounds with a plus or minus charge, but that are not ionic bonds but covalent bonds. And there are many of them in the human body, most of the times in solid forms in the human body. Ionic bonds as compounds are most of the times in the teeth and in the bones. Such thing like natrium chloride or sodium chloride can dissolve in water, dissociate in water, and when it is an electrolyte, because they are now plus and minus after again having dissociated again, and they can carry now an electric charge that makes them an electrolyte. And that is according to Gerard Tatoga and Sandra Gabrowski's Principles of Anatomy and Physiology book on the page 30 and 31. If you turn this video off at one point, then please tell me what the reason for it was so that I can improve. Otherwise, hi and welcome. I am trying to learn biochemistry today, ionic bonds, and after we've done what we're going to do squat training. And if you participate in the squat training, then it's better the arm risk. Ionic bonds, we try to read it, to gather the information together, memorize them, and try to save them from memory. Ionic bonds. When an atom loses or gains a valence electron, ions are formed. So an electron on the outermost shell is loosed or gained, and that creates then an ion, firstly. Positively and negatively charged ions are attracted to one another, opposites attract. When this force of attraction holds ions having opposite charges together, it is called an ionic bond. When it is held together by a positive ion and a negative ion forcing each other together, it is called an ionic bond. Consider sodium and chlorine atoms to see how this happens. Sodium has one valence electron. If sodium loses this electron, it is left with the 8 electrons in its second shell, a complete octet. When this happens, however, the number of protons in total exceeds the number of electrons. As a result, the sodium atom becomes a cation. So if this is positive, it is a cation. A sodium ion has a charge of 1 plus or +1 and is written Na plus, sodium plus or natrium plus, so sodium plus. On the other hand, chlorine has 7 valence electrons. If chlorine gains an electron from a neighboring atom, it will have a complete octet in its third electron shell. Chlorine has 17 electrons. Here's it. When this happens, the total number of electrons, 18, because it had gotten 18, exceeds the number of protons, 17. There's originally the same number of protons as electrons in an atom. And the chlorine atom becomes an anion. So cation plus anion. If it gains, it becomes an anion. And it is a -1. A negatively charged anion. The ionic form of chlorine is called chloride ion. And the other thing was sodium and then sodium ion, I think. Is it somewhere in? A sodium ion has a charge of +1. So sodium ion and now chloride ion. The ionic form of chloride is called chloride ion. It has a charge of 1 minus and is written Cl minus, chloride minus. When an atom of sodium donates its so valence electron to an atom of chlorine, the resulting positive and negative charges pull both ions together into an ionic bond. The resulting compound is called sodium chloride, written NaCl, so natrium chloride, sodium chloride. Sodium is written Na because in Latin it is natrium. In general, ionic compounds exist as solids, with an orderly repeating arrangement of the ions as in a crystal of natrium chloride. So they're mostly as a solid ionic compound, these ionic compounds or these ionic bonds. A crystal of natrium chloride may be large or small. The total number of ions can vary, but the ratio of natrium plus, sodium plus and chloride minus is always 1 to 1. So there's always one sodium and one chlorine in it, in natrium chloride. In the body, ionic bonds are found mainly in teeth and bones, and they give great strength to the tissue. Most other ions in the body are dissolved in body fluids. An ionic compound that dissociates into positive and negative ions in solution is called an electrolyte, because the solution can conduct an electric current. The chemistry and importance of electrolytes are discussed in detail in chapter 27. Let's read the sentence again. An ionic compound, so natrium chloride, an ionic bounded thing together, that dissociates into positive and negative ions in solution is called an electrolyte. So when it's split up, it's no longer a bond. It's no longer natrium chloride, it's been sodium and chloride. We're just going to say it as it's written here. If for example the ionic compound or ionic bond natrium chloride, sodium chloride dissociates in water in a solution, then we're becoming electrolytes, because they have dissociated into positive and negative ions, and they can now conduct electrical current. When a single positively charged ion of sodium and a single negatively charged ion of chlorine form an ionic bond, the net charge of how can it be a positively charged ion of sodium? Don't we just gain or lose an electron as soon as we're bound up together? So it doesn't go hand in hand. How can one happen without the other? Maybe it can. They could be bounded up together, then having dissociated, split it again as an electrolyte, and now we're having 1-1-1. And we would stay like that. Why don't we give back the electron when they are dissociating again? Or did we get it wrong, and when they are dissociating in a solution, they don't splitting up? I think they split. When you put single positively charged ion of sodium and a single negatively charged ion of chlorine form an ionic bond, the net charge of the resulting compound natrium chloride is 0. The same is true for every compound with ionic bonds. The net charge of a compound is 0. Okay, every ionic compound after the ionic bond has happened is always 0, the charge. In your study of a human body, however, you will discover many compounds that are positively or negatively charged. For example, ammonium and hydroxide are very common ionic compounds found in the body. The reason these compounds can carry a charge is that they are the result of covalent bonds, not ionic bonds. But there can be compounds, but they are not ionic bonds, they are then covalent bonds. And these covalent bonds, that one is putting the other one stronger, that must be that, so it becomes a polar covalent bond. It gets electronegativity. Is that the reason? But is that the reason for the howlet? It wasn't said yet. My assumption is that it is because of the polar covalent bond, that one atom is pulling stronger at the electron, but the total amount of a compound must be again net 0. Okay. The informations, ionic bonds, if something is happening, one atom loses one of the valence electrons or gains one. And the positive one attracts a negative one. Sodium chloride would exist. Sodium has 10, has 11, and the other one, chloride, has 17. It could get one, be 18 and full, the other one could lose one, be 10 and again full, but now on the second shell. It's called a cation if it is positively charged. So sodium would be a cation and chlorine anion. They can come together forming natrium chloride. Such a coming together has always a net zero charge if a +1 and a -1 have come together. And all ionic bonds formed to a compound have always a zero charge. There can be compounds with a plus or negative charge, but they are not ionic but covalent bonds. Also all. And ionic compounds can dissolve, and they are then, because they can conduct electric current, electrolytes. They are mostly solid in bones and teeth in the human body. And they are always 1-to-1 in that compound, or in that crystal of natrium chloride. As an example, we don't have time left. That's not again. Ionic bonds. By ionic bonds, there's always one atom losing or gaining one of their valence electrons, so the electrons on the outermost shell. And there can be, for example, sodium. Sodium has 11 electrons, 2 on the first shell, 8 then on the second shell, and 1 on the third shell, and that one single valence electron can be given away, and now it becomes with a full octet on the second shell, and it becomes now sodium. And it is now a cation because it has too many protons. It has still these 11 protons, but only 10 electrons. No, it has one too much protons. It has now a charge of +1. Because protons are +1, electrons -1. Another example would be the chlorine. Chlorine has 17, and chlorine could gain an electron, has been 18, and it has no electron too much, so it is too much minus. It is now -1, and now an anion. Cation is positive, and anion is negative. And they can come together and form then sodium chloride, for example, and then they have again a net zero charge. All ionic bonds as a compound form together, for example, sodium and chloride, as sodium chloride, they have a net zero charge. There can be such compounds with a plus or minus charge, but that are not ionic bonds but covalent bonds. And there are many of them in the human body, most of the times in solid forms in the human body. Ionic bonds as compounds are most of the times in the teeth and in the bones. Such thing like natrium chloride or sodium chloride can dissolve in water, dissociate in water, and when it is an electrolyte, because they are now plus and minus after again having dissociated again, and they can carry now an electric charge that makes them an electrolyte. And that is according to Gerard Turga and Sandra Gabrowski's Principles of Anatomy and Physiology book on page 30 and 31. I think I forgot at least one thing. I don't know, maybe it was a thing. I'm going to stop the camera. And that was the biochemistry part. If you were here for biochemistry, you can go directly to the next part of biochemistry. If you stay here and participate in the squat training, then it's better the arm wrestle. One leg up. The other one. Take the leg at the ankle. Go straight back, knee down to the ground. And one leg to the side, torso pointing in front. Just stretching the inner side of the leg. The other side. And go from side to side. And back into the leg. And now do the squats. Legs wide apart. And we're doing 12 squats. So the first one, and the second one, and the third one, and the fourth one. And with number 5, and then the 6 we have in half. So I was at 5 or 6, so these are 6. So 7 and 8, and number 9 and 10, and the last 2, namely 11 and 12. And up again. And now the 6-pack squat squeeze exercise. Down into quarter squat and press against the top of the leg on one side to train your obliques. And on the other side. And halfway down and press against the middle of the leg. And on the other side. Down to the 3/4 squat and press close to the knee. And on the other side. And up again. Now the fastest giraffe of a water pond exercise. Down into 3/4 squat, press against the leg, go towards it. On the other side, press, go towards it again. Press, go towards it. Press, go towards it. 2 more. Press, press, and up. Now the propeller. Down into foot squat, arms to the side, over to one side, press against the leg, look up to the hand. The middle, over to the other side, press again. And up. And again, one leg up. The other one. One heel onto the ground, pull the toes in. Put to the left, pull the toes in. To the right, pull in. Middle and move the leg. Other heel onto the ground, pull the toes in. To the right and pull in. Left and pull in. Middle and move. And take the leg at length. Straight back, knee down to the ground. Next vertical part, breathing it on. There we go. In another round. Out. Breathing across the legs. And breathing out. It was squat training. I thank you very much, and until next time.